Hi guys, welcome you all to my channel Explore Edu to Teach.
The next topic that we'll be taking up in signal and systems is Laplace transform. Laplace transform is a very important concept not only in this subject but also in mathematics and so many other subjects because Laplace transform is used widely. So please make it a point that you understand this concept well. We are going to talk about what is Laplace transform in this particular video. We are going to talk about the ROC, that is region of convergence of Laplace transform, and then we are going to try to learn some formula and apply them onto a numerical. The next video is also going to be on Laplace transform itself, wherein we are going to solve some numericals on convolution. But before doing that, you need to know what is Laplace transform, how do you apply the different formulas of Laplace transform onto some basic numericals, and then we do the higher end numericals. So please make it a point that you watch this video till the end because it's going to be extremely beneficial for you. And do not forget to like, share, subscribe to my YouTube channel. Also follow me on Instagram. All these formulas which are present in this particular video are present in the form of a consolidated way in my Instagram page also, that is Explore Edu to Teach. The links are given down in the description box. Please follow me over there also. There you will get regular updates of all the short videos, formula sheets which are going to be extremely helpful for you in your examination and in your studies. So please do watch out this space and let's begin up with this concept of Laplace transform. So what is Laplace transform basically? Laplace transform converts a time domain signal into a complex frequency domain. The complex parameter is basically S is equal to sigma plus j omega. So basically Laplace transform converts my time domain signal into a complex frequency domain, wherein my complex frequency domain will be given as S is equal to sigma plus j omega. The sigma is the real part, omega is the imaginary part, and try to find out the answer. So the Laplace transform of a particular signal x of t, which is a continuous time domain signal, is given as Laplace transform of x of t is equal to integration minus infinity to infinity x of t e raised to minus st dt, and the symbol is given as capital X of s. Now the limits of integration goes from minus infinity to infinity, which is called as two-sided or bilateral. The limits of integration can also go from 0 to infinity, which is just one-sided or unilateral. So talking about Laplace transform, it's a particular technique in which I am going to convert my time domain signal into a complex frequency domain. It is given as S is equal to sigma plus j omega, wherein sigma is the real part, omega is the imaginary part, which is given over here. The mathematical equation of Laplace transform is given as Laplace transform of x of t is equal to x of s is equal to integration minus infinity to infinity x of t e raised to minus st dt. The limits are minus infinity to infinity if it is a two-sided Laplace transform, but if they ask you a single-sided or a unilateral Laplace transform, just take it from 0 to infinity itself. So note this formula very well. It is present on my Instagram page also. You can check it there as well. The notes are present in the description box of this video also. You can check it from there also. But remember this formula very well. That is Laplace transform of x of t is given as integration minus infinity to infinity x of t e raised to minus st dt. Now there are three forms of ROCs in case of three cases of ROC for that matter in Laplace transform. One is the right-handed causal signal, the next one is the left-sided anti-causal signal, and the third one is a two-sided non-causal signal. So talking about the first one, right-handed causal signal. So the x of t is given as e raised to minus at u of t. The Laplace transform of x of t is given as x of s, which is 1 upon s plus a. These are the basic formulas of Laplace transform. So if I talk about the right-handed causal signal, the sigma, that's the real axis, is going to be greater than minus a. So if I draw the sigma and j omega graph, it's going to be greater than minus a. Hence it's considered to be right-handed causal signal. If I consider the left-handed anti-causal signal, the x of t is given as e raised to minus at u of t, u of minus t, that is minus 1 upon s plus a. and the sigma is given smaller than minus a. Now this is given as smaller than minus a, which forms the left hand side of the signal, and hence it is given as anti-causal signal. If you see its anti-causal signal, it is given as u of minus t as well. So I hope I am very clear with this. Now when I talk about a two-sided non-causal signal, it is a combination of, if you see, right-handed signal which is u of t and a left-handed signal that is u of minus t. So if you look at the signal given as x of t e raised to minus at u of t plus e raised to minus bt u of minus t. So remember this thing. Now if I talk about u of t e raised to minus at, the Laplace transform is given as 1 upon s plus a. And if I talk about e raised to minus bt u of minus t, it is given as minus 1 upon s plus b. Now sigma is given as greater than minus a for a causal signal, and the sigma is given smaller than minus b for an anti-causal signal. So remember that a causal signal is given as u of t, an anti-causal signal is given as u of minus t. So remember this thing very well. So if I talk about right-handed causal signal, it is given as u of t as sigma greater than minus a. This is the graph. Left-handed signal is u of minus t, it is sigma smaller than minus a, whereas a two-sided non-causal signal is a combination of greater than minus a and smaller than minus b, which is a combination of causal as well as anti-causal signal. Hence we have greater than minus a, smaller than minus b. This is a part of my ROC. So this is very important for you to understand. Next, there is two very important formulas. Please make a note of it. As I mentioned, the notes are present in the description box of my YouTube video also. It is also present on my Instagram page as well. The links are given in the description box. So you can always note the formula from there, but make a note of it right now only. The Laplace transform of dy by dt, a differentiated form of output signal y of t, is given as minus y of 0 plus s into y of s, whereas y of s is nothing else than the Laplace transform of y of t. And Laplace transform of d square y upon dt square is given as minus y dash of 0 minus s into y of 0 plus s square into y of s, where y of s is nothing else than the Laplace transform of y of t, and minus of y dash of 0 is given as the differentiated form of dy of y of t with initial condition given as 0. Now if I just consider this thing, the convolution in time domain is basically multiplication in frequency domain. This is a very important property. Make a note of it. So when there is a convolution happening of two time domain signal, the frequency domain will have the multiplication of their Laplace transform. So x1 of t is x1 of s, x2 of t is x2 of s. So the convolution is given as x1 of s into x2 of s. So we have a particular question which we will be solving in this video. There will be another video coming up in which you will be having more problems solved on Laplace transform. So please understand these concepts very well. Make a proper note of this numerical so that it becomes easier for you to solve other numericals also, which will be solved in the future videos. The question says, using Laplace transform, determine the natural response of the system described by the equation d square y by dt square plus 6 into dy by dt plus 5 into y of t is given as dx by dt plus 4 into x of t, with initial condition as y of 0 as 1 and the differentiate form of y of t at t is equal to 0 as minus 2. You have to find out the response of the system. What do you mean by the response of the system? That means you have to find out from this entire condition given y of t. So what we are going to do is that we are going to apply, since they asked you to find out the natural response of the system, in natural response x of t is given as 0. So the entire equation will have the right hand side becoming equal to 0. And in the left hand side we can apply the Laplace transform. So when I apply the Laplace transform to d square y by dt square, I have already told you the formulas over here. It says minus y dash of 0 minus of s into y of 0 plus s square into y of s. Laplace transform of 6 into dy by dt, 6 comes outside since it's a constant, minus y of 0 plus s into y of s, plus Laplace of phi into y of t is given as plus phi into y of s equals 0. Now just substitute these values of y dash of 0, y of 0, which is given up in the question. So just substitute these values. Try to find out y of s will be given as s plus 4 upon s square plus 6s plus 5. So the y of s is given as s plus 4 upon s square plus 6s plus 5. So you can break this as s plus 4 upon s plus 1 upon s plus 5. Here simple partial fraction is applied in order to find out the final answer. So this is completely solved in the form of a partial fraction. You can go through it. It is present in the notes also, which is present in the description box of this video. Go through it, solve it, see how you can get it into the time domain form by this partial fraction method. So you can get 3 by 4 s plus 1 plus 1 by 4 s plus 5. So 3 by 4 is a constant. S plus 1 can be written as e raised to minus t u of t, considering it has to be causal signal. 1 plus 4 e raised to minus 5t u of t, considering as causal signal. Since nothing is mentioned in the question, you can consider as causal signal by default. And the ROC will be given as sigma greater than minus 1, because sigma will be greater than minus 1, sigma will be greater than minus 5. So the common one will be sigma greater than minus 1. So this is very important. So please make a note of it. So in this particular video, we talked about the Laplace transform, the very important formula of Laplace transform in unilateral, bilateral, both ways. The ROC is present in the Laplace transform. The formula of dy by dt, d square y by dt square. Convolution in time domain becomes multiplication in frequency domain. This is a particular equation, so just try to find out the value and get the final answer. So this is very important, so please make a note of it. And if you like the video, do not forget to like, share, subscribe to my YouTube channel, follow me on Instagram. Please share it to as many people as you can who can get benefited out of it. There will be a new video coming out very soon on the problem solving of Laplace transform, wherein we will be basically dealing with this property of a Laplace transform, that is convolution in time domain becomes multiplication in frequency domain. So we'll be solving numerical on that and certain other properties as well. So like, share, subscribe to my YouTube channel, follow me on Instagram. A new video will be coming out very soon. So thank you so much guys.